Welcome! Today we'll solve the homogeneous second-order linear differential equation y double prime plus 2y prime plus y equals 0. To solve this equation, we'll follow these steps. First, we'll find the characteristic equation. Then, we'll solve for its roots. Finally, we'll use these roots to write the general solution for y of t. Let's start with finding the characteristic equation. We assume a solution of the form y equals e to the rt, where r is some constant. This means y prime equals r times e to the rt, and y double prime equals r squared times e to the rt. Now, let's substitute these expressions into our original differential equation. We get r squared e to the rt plus 2, r e to the rt plus e to the rt equals 0. Factor out e to the rt, since it's in every term. This gives us e to the rt times quantity r squared plus 2, r plus 1 equals 0. Since e to the rt is never 0, we can divide both sides by e to the rt. This gives us our characteristic equation. R squared plus 2, r plus 1 equals 0. Now for step 2, solving for the roots. This is a quadratic equation. We can solve it using the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Here, a equals 1, b equals 2, and c equals 1. Let's substitute these values into the quadratic formula. We get r equals negative 2 plus or minus the square root of 4 minus 4 all over 2. This simplifies to r equals negative 1 with multiplicity 2. Finally, step 3, writing the general solution. Since we have a repeated root, r equals negative 1, our general solution takes the form y of t equals c1 plus c2t all times e to the negative t, where c1 and c2 are arbitrary constants. And there you have it. We've solved the homogeneous second-order linear differential equation y double prime plus 2y prime plus y equals 0. The general solution is y of t equals c1 plus c2t times e to the negative t.